Dream to become the next Sir Isaac Newton or Albert Einstein? Learn calculus from Refath Bari, aka 800 over 800 guy, is teaching calculus this year. Watch his videos.
Alright folks, so what's up? This is Refath Albert Bari from My Science Lab. Today I'm going to be doing more examples of quotient rules. As you can see, quotient rule practice. We're going to be doing 3 examples of the quotient rule because our last video covered the proof of the quotient rule. So let's go ahead and get started. So already we're facing technical difficulties, but that's okay. So this is our first problem, right? Find the derivative of the quotient of 3x to the 4th minus 2x cubed over 5x squared plus 3x. Now, if you recall the quotient rule, which I covered, whose proof I covered in the previous video, the quotient rule states that if I have a function f of x, right? Why is this blank? If I have a function f of x, which is the quotient of the function g of x and h of x, then the derivative of my function, which will be denoted as f prime of x, will be the derivative of my top function g of x times my bottom function minus the derivative of my bottom function. Let's erase this. Minus the derivative of my bottom function times my top function, all over my bottom function squared, so h of x squared. Right? So that's what that's what the quotient rule is. It tells you how to evaluate the derivatives of a function that's the quotient of 2 other functions, or 2 other terms, or polynomials. So this is basically what the quotient rule states, right? So I'm going to keep this in the background so that we can refer to it later on. But for now, let's keep on going and try to evaluate this derivative right here. But before we do that, let me quickly write the quotient rule right here. G prime of x, h of x minus g of x times h prime of x all over h of x squared. Right? Where f of x is defined as the quotient of g of x and h of x. Okay, so now that we have the quotient rule down, let's try to go ahead and solve this derivative, shall we? So how can we solve this derivative? Well, first things first, let's identify the top and bottom of this fraction. This is going to be our top, and this is going to be our bottom, right? So I'm going to use 2 different colors for that. I'm going to use blue for my bottom function and green for my top function. So let's go ahead and denote that. This is my top function, and this is my bottom function, right? Okay, so let's go ahead and evaluate the derivative of this function. How do we do that? Well, begin by evaluating the derivative of the top function. So we're going to write t prime times b minus, minus, let's make that better, minus the derivative of the bottom, right? So the derivative of the bottom times the whatever's on top. And we divide all of that by the bottom function squared. So I'm going to write b squared. Okay, now all we have to do is plug in, right? Let me erase this. So this is b. Okay, So, what is the derivative of my top function? Well, what's the derivative of 3x to the fourth minus 2x cubed? Well, I'll evaluate that very soon, but for now, let's just write, shall we? 3x to the fourth minus 2x cubed. We'll take the derivative of that, and then times bottom function 5x squared plus 3x, and from that we will subtract. Once again, we're gonna take the top function 3x to the fourth minus 2x cubed. This time we will not take its derivative, but in the same we will take the derivative of the bottom function. So, and remember that we divide all of this by the bottom function squared. Okay, so what is the bottom function squared? Well, what is, let's just find. The bottom function squared is simply going to be 5x squared plus 3x squared. Right? That's all the bottom function is. And let me write this in black ink so you don't get confused, because the squaring part is not actually part of the function itself. Alright, and let's go ahead and color code this as well so that we remain consistent. 3x to the fourth minus 2x cubed. So 3x to the fourth minus 2x cubed. And of course, I'm going to review once I finish taking the derivative, so you folks can understand what I'm actually doing. And on the bottom, I have 5x squared plus 3x. Okay, so what are we doing? Well, we're evaluating the derivative of this function. This function is the quotient of two polynomials, right? The top polynomial is 3x to the fourth minus 2x cubed, and the bottom polynomial is 5x squared plus 3x. Now, what do I mean when I say evaluating the derivative? Well, let's say our function, this function will be quadratic. It will look like some kind of a quadratic. Our function will look something like this, right? It's a quadratic. And taking the derivative of our function at any point, let's say this point, for example, let's say this point is x, and this is f of x. Taking the derivative at this point will give me the slope of the tangent line at this point, right? So that's what I'm really doing when I'm taking the derivative. I'm trying to find the slope of the tangent line. And the tangent line, remember, is simply, let me show you an example. The tangent line, as we covered in our first few videos, is the line whose slope approaches the slope of the function at a certain point. So for example, if I have this function, right? Let's go with the basic y equals x squared. Right? This is y equals x squared, correct? Now, let me take a point x from here. Right? And let me say that the value of x over here is going to be f of x. So that's going to be my y plus x. Well, when I say I'm taking the derivative of this function at x, what I'm really saying is that I'm trying to find the slope of this tangent line at x. Okay? So that's essentially all the derivative is. And yeah, so let's keep on evaluating the derivative of this function using the quotient rule, which you recently learned. So, how do we do that? Well, let's evaluate this derivative. Remember, the derivative of a difference is simply the difference of two derivatives. So, 3x to the fourth, we're going to use, let me get my red pen here. We're going to use the power rule, right? So, take this 4 and multiply it with the coefficient of 3. So what's 4 times 3? Well, that's simply going to be 12, right? So 12. And then I reduce the exponent by 1. So 12x to the 4 minus 1, which is simply 3. Okay, continue doing that. Same thing here. I use the power rule to multiply this exponent with this coefficient. 3 times 2, well, that's just 6. And I reduce this exponent of 3 by 1, so that I get x squared instead of x cubed. Alright, remember, we're not taking the derivative of the bottom function yet, because as you can see, there's no sign like that. There's no prime sign. So we just leave it as it is. 5x squared plus 3x. Now, from this we subtract. Whoa, why is it black? Why is it red? Okay, from this we're going to subtract the derivative of the bottom function. But let's first write out the top function. 3x to the 4 minus 2x cubed, and multiply that by whatever the derivative of our bottom function is going to be. So let's get our red pen here. So how do we compute the derivative of this polynomial? Well, just like we did with this one, we're going to start by using the power rule. Why? Because you have a power here, you have an exponent. So I'm going to take this exponent of 2, I'm going to multiply it with this coefficient of 5. Right? 5 times 2, well, that's just going to give me 10. That's better. So 5 times 2 is just going to give me 10. Okay. And remember, I'm going to reduce this exponent of 2 by 1, so that I simply get 1, which I can just write as 10x. And here, this is a special case, you might get confused. I have 3x. How am I going to use any power rule? Well, remember that there's actually an invisible 1 as your exponent right there. So take this 1, multiply it with your coefficient of 3. 3 times 1 is simply 3. And reduce your exponent of 1 by 1. So that 1 minus 1 gives you an exponent of 0. Anything to the power of 0 is simply 1. So we can just write 3. Just like that. And we're almost done. Now all we have to do is simplify this. But first, let me write the denominator. Right? Remember, all of this is divided by 5x squared plus 3x whole squared. So 5x squared plus 3x whole squared. Okay, we're almost there. Let me erase this top part, or if you want you can grab a screenshot, but I'm going to erase this top part so that I get more space. Why don't I use the eraser? Alright, and remember this was bottom square. Okay, so what do we do now? Well, now all we have to do is simplify. Now that we've taken the derivative, let's just simplify this. So, oh by the way, this is 3x to the 4. Sorry, got cut off. Okay, let's go ahead and simplify this. Right? Just a simple distributive property, and just go ahead and simplify this. I'm sure you can do that on your own, and that's it. That's all there is to finding the derivative of a quotient. All you have to do is use this, the quotient rule. Alright folks, so thank you for watching, and we'll see you next time.
To fall in love with math and science, especially programming.